You ever look at a problem and just your brain shuts down? You don't even know where to begin? Well, what if I told you there's a systematic way to tackle any challenge, whether it's a tricky word problem or, a huge project at work? Today, we're going to unlock a powerful 6-step thinking tool that will completely change the way you solve problems.
Oh yeah, we've all been there. You're just staring at a page of words and numbers, and you feel that little knot of panic in your stomach. Your mind just goes completely blank. It feels like you're supposed to pull the answer out of thin air, but the path from A to B is totally invisible.
I mean, look at this. You've got herbal solutions, weirdly specific volumes, a target number. It's a jumble of information. And that feeling of anxiety, it's not because you're bad at math. It's about not having a roadmap, not having a reliable place to start. And that feeling of being stuck is exactly what we're going to fix today.
So here's our game plan. First, I'm going to introduce you to your new secret weapon, this 6-step thinking tool. Then, we'll put it to the test with 2 totally different problems to show you how it works. And finally, and this is the important part, we'll see how you can use this for everything in your real life, way beyond math class.
Okay, let's get into it. The method we're talking about is basically a way to think like a computer, and I mean that in the best way possible. It's about breaking things down logically, step by step, so nothing feels overwhelming. Think of it as a universal toolkit for your brain.
And here they are, the 6 steps. We've got decomposition. That's just breaking it down. Pattern recognition, finding the clues. Abstraction, ignoring the junk. Algorithms, making a plan. Logical reasoning, using your brain. And finally, evaluation, checking your answer. I know it might seem like a lot right now, but you're about to see how simple and crazy powerful this is when you put it into action.
All right, enough theory. Let's get practical. We are going to take this 6-step tool and throw it at that first problem we saw, the one with Professor Faisal and his herbal solutions. Time to see if this thing actually works.
So, just to remind you, here's the challenge. We've got 4 different volumes. We need to find the exact combination of 3 of them that adds up to 1,430 milliliters. So, where do we even begin? Well, we begin with step 1. First up, decomposition. This just means we take that messy paragraph and break it into clean, simple parts. What's our goal? 1,430 milliliters. What are our tools? Solutions A, B, C, and D. See? Right away, it's not a scary paragraph anymore. It's just an organized list, much easier to handle.
Now for step 2, pattern recognition. And this is where we get to be clever. Look at our target number, 1430. It ends in a 0. That is a massive clue. It means that whatever 3 numbers we pick, their last digits have to add up to something that also ends in a 0, like 10 or 20. That little detail is about to save us a ton of work.
Okay, next is abstraction. Think of this as decluttering the problem. Does it matter that they're called herbal solutions or that some guy named Professor Faisal is involved? Nope, not at all. All of that is just noise. We're going to ignore it and focus only on the numbers and the goal.
Step 4, creating an algorithm. Now, algorithm sounds like a big, scary, techie word, right? But it's not. It's just a recipe, a set of steps you can repeat. Our recipe is super simple. 1, pick 3 numbers. 2, add them up. 3, see if they equal 1430. That's it. That's our plan.
And this is where it all comes together. Step 5, logical reasoning. Remember that pattern we found in step 2? About the last digits needing to add up to 10? Well, let's look at the last digits we have. A 2, a 5, another 2, and a 3. Which 3 of those add up to 10? Only one combination, 5 plus 2 plus 3. That means solutions B, C, and D are our only possible suspects. We don't even need to test any other combinations. How cool is that? And for our final step, evaluation, the moment of truth. Let's add them up. 485 plus 482 plus 463, and what do we get? 1430. Bam! It's correct. The system worked perfectly. Okay, so that worked like a charm for an addition problem. But was that just a fluke? Will it work on something totally different? Let's find out. We're moving on to case study number 2, which involves distance, dates, and a little bit of division.
Here's the new puzzle. We know the round trip or two-way delivery distance is 86 kilometers and 900 meters. And by looking at this calendar, we need to figure out 2 things, the one-way distance and the total distance driven for all the deliveries in the whole month.
And you know the drill by now. Step 1, decomposition. Let's pull out the key facts. Fact 1, the round-trip distance. Fact 2, Let's count the circled dates on the calendar. Yup, that's 7 trips. And we have our 2 clear goals. Find the one-way distance and find the total distance. Now for pattern recognition. We can see the deliveries happen every 4 days, which is a pattern. But the crucial pattern here is the unspoken rule. The delivery distance is the same for every single trip. It's constant. That consistency is the key to solving this.
Time for abstraction. Let's filter out the junk. Do we need to know that it's April? Or that the 4th was a Saturday? Nope. All we care about is the distance number and the fact that there are 7 trips. Everything else is just distracting information. So what are our algorithms, our little recipes this time? Well, for the first goal, our plan is to take the round-trip distance and divide it by 2. Easy. For the second goal, we can just take that same round-trip distance and multiply it by 7. 2 simple, repeatable plans.
In step 5, logic. This is really just common sense, right? We already established our pattern. The distance for each trip is the same. So it logically follows that the total distance for the whole month has to be the distance for one trip times the number of trips. It just makes sense.
Finally, let's evaluate. We run the numbers. 86 kilometers and 900 meters divided by 2 gives us a one-way distance of 43 kilometers, 450 meters. Then, 86 kilometers and 900 meters times our 7 trips gives us a grand total of 608 kilometers and 300 meters. We double-check our math, and we're done. Problem solved.
So we've just watched this tool completely tear through 2 different math problems. But here's the real secret. This was never just about math. This is a framework for thinking, and you can apply it to pretty much anything life throws at you.
Think about it. This is your real-life superpower. Planning a big trip? That's decomposition. Breaking it down into flights, hotels, activities. Trying to get your budget under control? That's pattern recognition. Finding the trends in where your money goes every month. Feeling overwhelmed by a huge task at work? Abstraction is about identifying the one core issue you need to solve first. The checklist you make for a project? That's an algorithm. This isn't just a process. It's a whole new way of looking at any challenge in front of you. So the next time you feel that wall go up, that feeling of being totally stuck on a problem, don't panic. Just remember these 6 steps. Break it down, find the pattern, ignore the noise, make a plan, think it through, and check your work. You officially have the tool. So the only question left is, what problem are you going to solve first?